Alright, so here are the tutorial videos for the third homework, and after looking through this assignment I think some of it is kind of a review from the first two assignments, but let's go ahead and get started. Alright, so number 2, do you have enough data to fit the full model? That is with all 8 independent variables. Okay, so for this one you just need to refer to your PowerPoint 3B. It's actually right on slides 15 through, pretty much just on 15. So N stands for the number of observations, and K is your number of independent variables. So if you go ahead and download this territory data set, so right here you see there's 25 observations, so that would be N. Then K would be number of independent variables, and there are 8. So in order for there to be enough data to fit the model, for this one, for Doane's rule, that 25 divided by 8 has to be greater than or equal to 5, which it is not, and 25 divided by 8 is also not greater than 10, obviously. So it does not, pretty much you just say there's not enough data and show these two rules. So then Dr. Shiflett asks, how many could you realistically fit? How many independent variables could you realistically fit? So if you have 25 observations and then you go to K, 25 divided by 5, that would be greater than or equal to 5. So 5 independent variables would be the bare minimum that you could have. That's kind of pushing it. But since Evans' rule says it needs to be greater than or equal to 10, then 2 would work. 25 divided by 2, that's 12.5, so that's greater than or equal to 10. So if you'd say we would need anywhere between 2 and 5 independent variables and show your work a little bit, I think that would suffice for number 2. Alright, so let's go down to number 3 using the same data set. Alright, so this is kind of similar to what we've been doing. We're going to do fit the model with 4 independent variables, and we're going to be measuring sales. So just go right here to fit model. Y is your sales, and then you just add, let's see, time, potent, ADV, advertising I'd say, and then accounts. Alright, and then I know when I was in the class, Dr. Shiflett wanted us to show minimal report. We'd run that, and this is what you'd get. So here's your R square, adjusted R square, root mean square error, overall F test of the model, and statistical test of the slopes. And as you can see, it's a pretty decent fit, 0.82, closer to 1 the better, so that's a pretty strong fit. Alright, so number 4, is there multicollinearity in this data? I remember when I was in the class, the best way to, or the preferred way to show that is by showing your VIFs, and for that also, closer to 1 is the best. As it gets over 2, it starts to be a little bit of a concern, but not too much. Once it gets into 3, then then there's definitely some multicollinearity, but right here, you could say that it appears to be maybe a little bit of an issue with time and in accounts, but in general, not too much multicollinearity. So just show your VIFs, and the way I did that was right-clicked, went to columns, and just clicked on VIFs. So that'd be for number 4. And then for number 5, we did this last week or a couple weeks ago. If you're looking for outliers and high leverage points, what you need to do is click up here somewhere, click Save Columns. In order to find outliers, you need studentized residuals, and for high influence points, you need hats. And just remember that for outliers, if the studentized residual is, if you go over here, if it's outside of -3 and 3, then it is an outlier. Just scanning through here, it doesn't look like we have any outliers. Then your hat values, you have that formula that we used last time, and that is 2 plus k, or 2 times k plus 1 divided by n. N's your number of observations, so 25 in this case, and then k is your independent variables, and we used 4. Yeah, we used 4. So plug that in. If there's any h values, hat values that are higher than what you get from this formula right here, then it's a high influence point. Alright, so number 6, we also did this a little bit last week. List the assumptions. So you have normality, which you'd use just the residuals for this one, not studentized. So you have normality, linearity, equivariance, and independence. For normality, you just put your residuals in a histogram, and then for linearity, equivariance, and independence, you'd put your residuals on a scatter plot, and you'd compare those to sales. And yeah, we touched on that last week quite a bit, so I'm not going to really spend too much time on that. So let's go ahead and go on to 7. So now we're pretty much doing something very similar to what we did with the 4 variables, but we just have 2 variables now. So sales is your Y, advertising and accounts is your minimal report, if you run that. So let's see if we still have that one down here. Alright, so let's compare them side by side. Let's get our VIFs down here because we're going to have to explain that here shortly. Alright, so we can see everything. Okay, so as you can see here, your model with only 2 independent variables does have a slightly lower R-square and adjusted R-square, but as you can see, the VIFs are much lower. So here's one where you just need to explain a little bit, and really there's no right or wrong answer, just validate whatever you're saying. So you could say this 4 variable models strong is a better fit because the R-square is higher, or you could say this one's a better fit because the R-square and adjusted R-square are still pretty high and close to what they are over here, plus your VIFs are much lower, so you don't see any 2's down here, so that would be a strong point. So you could go either way, but just make sure you use some reasoning to justify your answer. Alright, so now I'm going to end this video, and then I'm going to start another one for questions 8 through 13. So I'll be right back. Thank you.